let's talk about creating and destroying our objects. This is also construction and destruction. If we take a look at the class members project in the classes folder, we can continue talking about what we have here. Now, constructor is how we specify how to create our objects. We'll talk a little bit more about that as well as we move forward, but we can specify multiple constructors. We'll talk about overloading constructors. That's specifying multiple constructors as well as overloading methods. But this is the entry point into our class. So how a method is described or a method is defined, and it tells us how we can access that particular method, and we have to access it the way we wrote it within our class, meaning that if we pass parameters, we have to also pass parameters. But if we create methods that also don't use parameters, then we don't have to pass them to use this particular method. We have to return values if we specify return value, etc. But when we create something, we have to use one of the constructors to create the actual object itself, the instance of our class. And this is the syntax. We've seen it. The class, the variable name, equals new, the name of the class. And if we were just to specify a default constructor, for example, we can just look at it without any parameters here. As you can see, we can have that up here as well. And we do. Nothing is getting passed there, but we are still initializing variables. So when you do that, you're going to initialize variables within your particular class, possibly if those were defined in that particular constructor. And this is how you would create an instance of this class as an object here, based on that constructor. But we did it this way. So we used a constructor that had a string, and if we slide back up, we look for that one with a string, and there it is. This is the actual constructor that we were using. And furthermore, there's another way. We'll see that when we look at the overloading. Now, this is how we create our object. We can just put in our variable, and then we can get the code hinting. No problem. And this is going to give us the information about our class. So we do know this. And we can use it as we want to. Now we can create another reference to the object by actually doing something like for example, to create another reference to that object, and we'll see more of this later. But that's also using the object. We've created it, we're using it, manipulating it. Well, you know what? At the end of it, we're done with it. This program works fine. There's no problems here. And you're probably saying to yourself, well, we didn't destruct it. We didn't use a destructor. We didn't specify null. Well, you don't necessarily have to even specify null if you don't want to. The way to get rid of it, and there is a destructor here that we can find. There's our destructor. This is how we do that with the tilde, and this is going to signify the default destructor here. Now, this is only necessary if you need to perform operations here. If you need to do something specific, something, set variables, do something, then you would do it here within the destructor. This is going to create more overhead, though, because our objects are going to be managed by .NET. Garbage collection is going to be managing how these objects are actually going to be released from memory. So when we drop out of the scope of what we're doing with this particular class, or any class for that matter, we could do this and turn it to null. Give it a reference. As we know, reference types can reference null. They can become null. So this is not referencing anything anymore. So we could do it this way. This is going to also dispose of our object. Now, there's no guarantee that the memory for this object is going to get used right away. This is still going to go into the garbage collection routines, as we're going to see. This is specifically not going to free the resources right away. It has to go through the process, the .NET managed process. So when a destructor is called, now this can be when the object falls out of scope, it can be when you specify null, a destructor is going to occur. And this is also called finalization. It can be called finalization. And that's more of an advanced way of working. Now, when you actually reference something to null, when you give it that state of null, this is actually going to call the destructor and if there is one. If not, then the unmanaged resources are going to be released. And this is normally what you do with your destructor. You release your unmanaged resources. Now, you could have file streams open, network connections, database connections. These are different things that can fall within that unmanaged area because it's something that is falling out of the scope of the environment of .NET possibly, and it's dealing with things that are running all over your computers and networks. Database connections, the file system, and network connections are very, very important things that we need to release those resources when we don't need them anymore. So if you don't have any of those unmanaged resources that you're using, then you don't necessarily need that destructor. Now, these destructors can also slow down memory, and they don't guarantee proper destruction of the actual unmanaged resources, so you have to really take care with that. Now, additionally, garbage collection is going to be taking place, and we'll see that when we take a look at the garbage collection videos.